Hello YouTube viewers, welcome to my channel Science for Technology. In today's show, Science Thursday, we're going to talk about switchable permanent magnet or on-off magnet, or sometimes it's also called as Magswitch, but that is a company trademark. So first we have to have a surface level understanding of permanent magnet. Now, one thing you have to understand, especially anybody who works with metal, almost everything becomes magically magnetized. However, a permanent magnet varies from those things for one specific reason. It creates its own persistent magnetic field. Basically, electromagnet is also a magnet, but it requires electricity. This puppy does not need anything. It's like, I'm here, I'm going to be stable for at least long enough time, like for example 50 years or 100 years. So get the point. Like when we are talking about permanent magnet, it is permanent. That's why it's permanent in its name. Now magnets always have two pole. It does not matter how many times you split it up. It does not matter. You can go down to not only to magnetic domain, you can go down to freaking atom level. It still will always have north and south. You cannot split them apart. You cannot make them monopoles, so to say. So fundamentally you can only make a dipole system always have north to south. Another aspect is whenever you have a lot of magnetic line going from one place to another, we call it magnetic flux. Now that is the core factor that defines like whether your magnet can hold, let's say, 1 kilogram or 100 kilogram. Now generally now the world has kind of settled down on magnets. Now two of these magnet systems are made primarily everywhere on the planet. That is ceramic magnets. Generally you will find this in your subwoofers, audio systems and all that jazz. And then you will find neodymium magnet found in expensive equipments. And neodymium is generally a better one, but they are also more expensive. So depending on your cost and intensity required, sometimes you may not want very intense magnetic fields. People will choose ceramic magnets, or maybe you can simply cannot afford neodymium, so you will buy that because neodymium magnets are expensive AF. Like I bought only 10 piece of neodymium magnet, 1 centimeter cube magnets. Those costed me around 1000 rupees, more than that, I think 1200 rupees. So they're expensive neodymium ones. Ceramic ones are much cheaper in comparison. So this is what we are talking about here. Now, what is the use of quote unquote magnets in, like, real world, so to say? Because many times magnet people think that it's a toy like thing or something that you put and forget, like let's say example your headphones, hard drives, things of that nature. But remove those things aside, there is a very serious requirement of magnets in metal working world. For example, welding welding ground clamps are also made out of switchable magnets. For example, you can have a magnet, basically switchable magnet like this. You put it on a surface and that's it. You turn it on, it's on. Now it's clamped. You don't have to find a edge where you can, like, clamp on something like that, because again, maybe you have an open pipe, a pipe that is already in a circuit. How the heck you gonna do grounding on that? It's very difficult if you don't have an edge to clamp on. So use magnetic system. It allows you to directly do on flat surfaces, and you can literally put it next to wherever you want to do the welding system. So ground clamp, people love this puppy. You can buy them on Amazon, or you can build your own. I have provided a video down below of a person making that inspired me to make my own switchable magnet. And that's step one. Another one is work holding and friction. For example, let's say you want to make a metal chair and you are, like, laying the piece down. You're not going to do that in a vise. You're going to do it like on ground level, or have a person sit there to, like, do things. They're big, they're clunky, but somehow you have to hold them in place. And you can try to do that with clamps, but clamps are not very easy, accessible, or, like, comfortable, so to say. So you can utilize magnetic clamps. They generally come in angles, so to say. So what does those angle mean? That angle simply allows you to, okay, put it here, magnetically attach it here, done. You already have a 90-degree, you can weld, done. So there is a very serious demand of these things. It's not just a toy kind of thing, or, like, luxurious kind of thing. It's like necessary requirement if you want to do fast enough work. So work holding, fixturing. Then you have lifting material. For example, let's say you have a plasma table and you cut your stuff up. How the heck you're gonna pull it up? Because you may think like, okay, I'm gonna grab it from the side. You have to understand plasma cut gives a very bad burr, so to say. So it's like a very rough, and if you put it unprotected human hand, by hand, so it's not safe for human handling. So how the heck you gonna do that? So you can have magnet coming from top and you turn it on, you pull it up, do that. So even for a small metal working shop, this sort of magnetic clamps, where they have a crane on the roof or just have a small crane arm, they utilize magnetic clamps for this exact reason. It allows you to handle sheet metals very effectively. So lifting and material handling, on-off magnets, awesome for that. And it's not an electromagnet situation where you will be like, okay, what happens if power fails? It cannot fail fundamentally, so to say. So another aspect for precision, this is like serious thing. Many times you have seen people using this puppy. So what is it's just a magnetic base with a dial indicator. Now that dial indicator can be changed with something else if you want. It could have like some sort of surface gauge, dial indicator, or it could have some sort of another magnetic attachment. But you need a way to hold this puppy somewhere reliably. Magnets are strong enough. Why don't you want to use screw holes or things of that nature? Again, where the heck you're gonna find that in a lathe? Lathes are big, their bed are huge, so you will not have a convenient mounting location. Magnetic system, I got this. Wherever you have strong iron based system, you can utilize this puppy. So there is a serious amount of use of these things. It's not just like toy children toy. No, it's a serious use, serious industry. So to understand switchable magnet, you have to understand some core fundamental principles. So fundamental principle is magnetic field have lines, so to say. So whenever you're talking about magnetic field, you're talking about lines or a group of lines, so to say. And they always have direction, like how electricity always have from high potential to low potential. Magnet always have from north to south. The line that leaves north pole always goes down to south pole. It's always this way. And these when you have a lot of these lines, we call them flux. So you take a volume of air and you have, let's say, 100 line going through it, that will be x variable of flux. You have 1000 line, that will be 10x. So that's what we are talking about. So that's why flux is such an important thing here. And magnetic flux, while it's independent kind of force, you cannot see it, it's not like electricity where it's like causing plasma through the air. It does have the ability to be guided. You can literally make it flow through, quote unquote, metal system, where you can literally shape these things. You can literally shape it in such a way where it's like, okay, don't go here, go here. You can do that if you can shape the magnetic flux, so to say. And guiding fixtures can give you control. So if you have a way to for magnetic basically lines to go somewhere, because you have to understand, in air they have encounter certain amount of resistance. In iron they have lower resistance, so generally they take the lower resistance path. It always happens the same way. And heck, ask anybody who designs motors. Like most of the thing is like figuring out how the heck you give magnetic field, like I want you to go here, don't go here. Like you can do that. So fundamentally that's what we are trying. Like we are guiding magnetic flux on a permanent magnet. Permanent magnet is giving out fixed amount of flux. It's like, okay, go over here or go there. You want to control that aspect. That gives you the on-off system. So that's the hypothetical principle, so to say. So how the heck you actually do it? What's the logic behind it? Basically, if you, let's say, make a fixture, for example, this is a 3D printed fixture that I made, a switchable magnet, prototype number 1. So is it magnetic? Short answer, not really. Like it does have some residual magnet. The reason is there is 4 magnet inside them. Like you can consider them into 2 main magnet. I have like 4 small ones magnet here, so they are acting in pairs, so to say. So that's why I said 2 magnets. So I have right now, because it's not sticking, the configuration is south north south north. Basically it's creating a loop. So these metal bar I have on top and bottom, they are acting as like a cap, end cap. They are acting end cap, so it's not leaking too much magnetic field. It's like almost off. Again, if I had a proper material and proper sizing, it will not even do minor stiction that is doing. But if I rotate them, instead of going from north south north south north south, I make it north north south south. So magnetic field will be expelled. I did that. So now the north north is on one side, south south is on another side. Benefit, it cannot go, it cannot create a self loop. It has to go from outside. It is forced, quote unquote, to come from air, meaning outside. Benefit, ta-da, I can make the system or drop it off. Because if I make the magnetic line goes inside, it's off. If I go outside, it's on. That's all there is to it. And how you achieve this, that's up to you. You can use magnets like I have, and grounding clamps have done that, or you can utilize fixtures, so to say. So if you don't want to buy multiple magnets, or you want to achieve all these with one magnet, one big magnet, if you want to, you can do that. Like that's how dial indicator stands are generally designed. It's basically they have a cylindrical magnet, but the pole is not on the basically pole of the cylinder. It's basically on the side. So you have north south. So lines are coming out. They don't want to go there. They don't want to go into air. They want to go into magnetically conductive materials, example iron. So they will go into iron and close the loop. That's why the loops is always closed. But if you rotate them in a certain way, aka 90 degree, the north and south ends up in a position where the loop cannot be closed. Fundamentally loop is not closed, so it has to go from outside. It has to go through the air. Magnet is now on. If it's only closing itself from the inside, it's off. If you send it outside, it's on. That's all there is to it. Now this may sound a bit weird, it may counterintuitive. You can watch hundreds of video or you can watch hundreds of animation. All you have to do, build it yourself. It's kind of cheap. So you build it yourself. Like with 2 magnets you can easily build it with like some nut bolts and all that. Like you don't need 3D printer, you can do that with metal rods and something like that. And this is my Mark 1, that's why I'm not showing it too much. I will design something a bit more efficient, so to say. So that's the logic behind it. Basically you're guiding magnetic flux. Go outside, it's on. Go in, like, you know, stay inside, it's off. That's all there is to it. And generally whenever you are talking about anybody who's shipping you magnet, they will put magnet in a situation where the magnetic field is closing on itself. That makes magnet safe. It will not like, you know, cling randomly, screwdrivers or things of that nature. So that's the logic behind it. Now these magnetic systems, their final father, so to say, is basically magnetic chuck. This is the granddaddy of them all, because surface grinder, this puppy allows our machined world to be very precise, very flat. Basically that's how you achieve high level of precision. When you want to make something flat, you send them through what we call surface grinder. That's the final stage of most machine product. So surface grinder requires some way to clamp parts. Now here's the problem: you can clamp anything and everything in a vise. That's awesome, but here's the metal have a kind of flexibility to it, especially if you're clamping them down, or let's say you have a big bar or something. You have a bar like this and you're clamping from this side, it will bow out. It will physically bow. Now that will not look like, it's not perceivable to human eye, but the moment you grind it like that and then you remove the vise, it will like have a dip, because it, like, you know, spring action happened. So fundamentally people want a universal way of clamping things. Like, I'm gonna clamp this down and it has to be absolutely clamped everywhere. How do you achieve that? Magnetic chuck. That's why the lines are there. Like, think of those is classified as poles, how many poles there are. The finer ones are generally used for small ones, but it allows you integrate precision, basically what we call precision positioning. So if you have a lot of small parts, you will get this puppy where you have fine pole magnetic chucks. If you want to something like solid, big, hunking metal, you are working with some serious passes, you are grinding away a lot of you know, material in one go, people will say stay away from a fine pole, go to big poles. So you're gonna be like absolutely solid, positively solid. So they are very powerful. Like, for example, if you put a hunk of material that is magnetic and below is the magnetic chuck, and somehow you turn the magnet on, bye bye to your hand. There won't be a hand left. These are fundamentally dangerous tools. Now I'm talking about magnets that, like, you know, I'm playing around with. But even this puppy, now on paper this is a N52 magnet, neodymium one, super expensive one. I paid a lot for this, but if you have true magnets, like true N52 magnets, and those are neodymium grade, if they are like a size of centimeter square to, like, let's say 5 centimeter square or 10 centimeter square, they're dangerous. As in, I have like pinched my skin with these things. Like, they will like pinch my skin a lot of time. It's painful but not dangerous. But if you did that with big magnets, yeah, that's dangerous, flat out dangerous. You can injure or end your life. It's serious thing. And you will see any sites like Patel Magnets in India is a very good source of getting neodymium magnet. They are specifically tailor made for magnets itself. So that's their, like, you know, main selling point. So you can find a lot of magnets, a lot of different shapes, size, configuration and all that jazz. Pole configuration, again, like north and pole. Where the heck north and pole is there? Because on a disc you can have like north and pole side or side to side depending on your requirement. So fundamentally you can buy a lot of magnet there, but even they are like flat out. It's like, dude, if you're buying big magnets, please be mindful, they will say flat out it's 18 plus magnet. You're not supposed to give these magnets to children because they can literally you know, bye bye fingers, so to say. So fundamentally it's a dangerous tool. Be mindful of this. So, and magnetic chuck, like, this is an industrial tool. Like, you have to be serious around it's magnet, a fridge magnet. No, this puppy makes your fridge, so please be mindful of this. So this was my presentation on on-off magnet. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.